Look, we've been lucky enough here to find a very simple representation for what we need. We just came up with one single query using a city, but in real life, things can get very messy. Sometimes you cannot even express what you need with one single query because you may need to access external functionalities through different Python functions and so on. So just to illustrate this use case, I split up this query here into different segments, and there's by far is not at all one proper implementation. So I insist once again, is just to illustrate the real life situations where complex queries, really complex queries, may experience something like this. You may need to execute one SQL statement for each individual row, let's say, of a result set that already sends you back thousands and thousands of data. So, yes, this will involve a lot of data traffic and compute. And you can imagine with client programming, this can be very slow and very compute intensive. So, once again, just to illustrate this idea, let's see one other possible implementation would be to have a Python function that returns average salary in a department. You see here we pass one department and so on. You have one global, let's say, query that returns you the managers, only the managers, with only the current salaries, not the projected salaries. Okay. At the end here, yeah, definitely here you have this sequence. So I encapsulated everything in a function. The function is called get new salts, and I pass a connection here. So once again, we're on client programming for now. Here at the end, get managers with current and projected salaries. And what we do, we get all managers, and for each manager, yeah, getting all managers, this will return an array of JSON objects with department, employee name and salary per row. So we get all managers, and for each individual manager, we just add one new column value, yeah, new salary, with a new query. Get average salary will execute an individual query with average salary per department. So yeah, I totally agree. That's a very inefficient implementation. We don't care about this. Yeah, once again, I cannot come up with a very complex query because it will be harder to transfer the know-how. So yeah, let's do it. Let's simply try to execute this one, yeah, just to make sure it works. So I will get back to the connector folder, and yeah, I will say Python, and this is called three row, the row implementation of Py. Okay, so this works. Yeah, this returns three JSON objects with you can see the new salary here and three different managers. I copied and basically I adapted the exact same implementation, but with Snowpark. Remember, there are just nuances here with the way you execute a query with SQL and collect, and basically that's all. Yeah, that's all it does. And remember, you get a session instead of a connection. So let's execute this one as well. I will say switch to Snowpark, and I will call a very similar file here. Okay, so it works. Is there a better way to do this? So definitely, what I'm concerned with here is the fact that I have to execute so many SQL queries on the client from the client side. So there will be a lot of traffic eventually back and forth in the network. Is there a possibility to bring all this code closer to where the data is in the database in Snowflake? That's a question, and yes, as you can imagine, Snowpark can help us here. I copied the same file, the exact same file from row, yeah, in the store proc here in under the Snowpark folder. Yeah, you can see what I mean. At some point, this is what I'll try to do. provide this as a store procedure implementation, all this as a store procedure implementation in Snowflake. So yes, you can. I can go on Snowflake and do create a procedure. We'll do it later on, but I'd rather do it in a different manner here. I'll show you what Snowpark does. Snowpark brings us a possibility to use decorators. For instance, there are several ways to do this, but you can say sproc and provide something here, and this will declare our function as a store procedure to be deployed there. It's not as simple as this, because first of all, let's import this sproc decorator. This comes from Snowflake Snowpark functions. Okay, so yeah, and the syntax I will simply copy and paste it from here because I did it before, and just to avoid spending so much time here. You see, I will declare this function, and this function should be called compute. Okay, that's a typical signature which is required, compute. And the session here should be of type session. Which session? Once again, okay, I remind you, this comes from Snowflake Snowpark import session. So this is session. Yes, I can be more specific here. Let's say this is returning what? This is returning a string, but this is not essential. What we have so far, yeah, this should do it. Some other change, as you see it here, this will return what? This returns a string, yeah, a JSON object. The way we call it now is different. This should be with, I will say, salt is session call. Okay, you have the session call, and yeah, this would be calc new cells. Okay, this should do it. You can see here, let's follow the signature of this decorator. You can pass a name. Okay, calc new cells would be sales salary would be the name of the store proc. Is permanent. This means okay, is not temporary. We'll declare it for good. Stage location. Yes, we have to create a stage. Just remember that we are, yeah, if you look here, we are in a specific database and schema. Okay, going back here, I created already my stage. Replace true. This means that if the function, if the store proc already exists, just replace it, just redeclare it again. And in packages, you can see here, I pass not just Snowpark, but I pass also a specific version. So you can imagine if you don't do a few of these steps, yeah, you'll get an error. But let's first run this, and then I will tell you exactly what I did to get this up and running. From the command line, again, I'm at the right place. Okay, I will say Python for store proc py. Okay, this worked. What happened on our database side? Let's have a look. If we look into the activity, we can see that at some point we call calc new cells, and okay, you can see this is our procedure. So behind the scene, a store proc was created. That's a one. Let's see better. Okay, that's a big one. Create or replace procedure. That's our procedure. Return string, language Python. So that's a Python store proc. It's volatile. It's declared as volatile. Runtime version. This is very important. It's for 3.9. Okay. And the package, as you can see here, I passed the package. By default, they will include the Cloud Pickle. Why is this? Because right now, If you look inside, they will actually pack these functions. They will compress it. They will. It's byte encoded. You remember the code, the Python code, is sent into the Python sandbox as bytecode. And yeah, they just for reference, they keep in a comment the actual definition of our function. But as you can see here, yeah, the handler should always be a compute. You pass a session always as first parameter. You can pass other parameters, but session should always come first. And they call the compacted function. They use pickle. Pickle is something to compress in a specific manner. Machine learning models, among other things, and so on. So yes, this is very equivalent with calling separately a create and replace function procedure. Yeah, from here, with exactly the same parameters here. And yes, inside you can actually pass the actual code. You don't need it compressed here. You have to initially go, and you'll do this once. You'll have to go to admin, the billing and terms, and you see here, Anaconda Python packages. You have to agree with this to enable this one. You do it once. For them, it's just to make sure, okay, they are covered legally if something doesn't work here for you. Something else, yeah, this is very interesting. I told you about uh, the Snowpark version, and if you go back to one of our worksheets here, let's say this one. Okay, let's select our specific database and schema. And if we call select from information schema packages, this is important, where the package name starts with Snowflake Park, okay, Snowflake Snowpark. Let's do this. You can see what they have for the runtime version that we have. Remember, we have 3.9, so we can actually add this as a search criteria, and runtime version is 3.9 because this is what we have installed. And you remember I told you, be careful what they have as last version, because sometimes they don't use the last version here. Okay, so I'll do it again. So for 3.9, yes, you can see they have 1.10.0, let's say, but what I had locally installed was 1.11, and this didn't work. You have to install it and to reinstall this one. So basically,